All right, good morning. So this is the chapter 22 notes. This chapter is kind of small, kind of light, but it's kind of a weird new thing. Its whole idea is what's called a student's T, which is kind of like a Z-score, a T-score, okay, p-value you get from your T-score. So essentially what this is it helps find probabilities given small samples. So we have not changed how we find our probabilities based on the sample size yet. We've always assumed that everything's going to work out just fine. But what happens is too many errors come up when you have a small sample size, because that sample size is not always the best reflection of the actual population of what you're trying to study. And so with smaller sample sizes, we have to account for more possibilities of these weird samples we collect. So we have to make some small adjustments. Okay, that's what's called the student's T. The method of testing a hypothesis of a small sample. The big vocab here is DF, okay, degrees of freedom. It's essentially the sample size minus 1. Okay, by subtracting 1 from your sample size, they say that's kind of what the right direction as far as trying not to make any errors, okay? So where we use a Z-score, we use the student's T. So when you think of a Z-score, if you're thinking of a small sample size, this is where a T-score comes in, okay? So I'll pause for a moment. Okay. And one more time, a degree of freedom, okay, is essentially just one taken away from your sample size. If you have a sample size of 5, your degree of freedom would just be 4. Sample size of 26, degree of freedom would be 25. Sample size is, maybe you've got a big population, and so a sample of, let's say, 160 is a small sample for your group, and so maybe you might want to knock it down to 159. Okay, and we'll discuss what that all means here in a problem. Okay, like what does that all mean? Okay, what do we do with that degree of freedom? All right, so we're just going to jump right to an example from the book as far as what we do with this whole student's T. And the problem we're going to do from the book, the example is going to be from page 587. So let's take a look at page 587. And let's see what that has to say about this whole student's T. Okay, so 587. So it says a one sample t-test for the mean. This is kind of the big idea here. So researchers tested 150 farm-raised salmon for organic contaminants. They found the mean concentration of the carcinogenic insecticide Mirex is to be 0.0913 parts per million with standard deviation of 0.0495. So in their sample, they found that to be the average, okay? The mean, right, was 0.0913. This is from the sample, with a standard deviation of the sample to be that, okay? As they state the recommendation for recreational fishers, the Environmental Protection Agency's, EPA, recommended screening value for Mirex is 0.08. Okay, so our farm salmon contaminated beyond the level permitted by the EPA, and we're going to go through the conditions. Everything looks independent. It looks to be random. All right, and so our null hypothesis will be that the mean is 0.08. That's the screened value. Okay, and we want to know, is it above that value? Is it really above 0.08? Okay, we got 0.0913, but we're testing against what they said it should not be over. Now, even if it's a little bit over, it's just a sample, so there's a chance that the sample is just a little bit over the average, but maybe there's a good chance that it might fall below the average. Okay, and that's where we kind of do this whole, all the stats we're doing, right? while we're doing this. Our null hypothesis, right, is that it is at 0.08, that it's not greater than, okay, 0.08. So we're testing to see if the sample collected proves that it's above 0.08, okay? So the sample size is 150, so our degree of freedom will be 149. The average value from the sample was 0.0913. Remember, that was the value that it's not supposed to be over. So we're comparing the value from the sample against that number, 0.0913. And the standard deviation of our sample was 0.0495. So finding the standard error of our sample, okay, take the standard deviation, 0.0495, and divide it by the square root of the sample size. So we're going back to the sample size of 150. So 0.0495 divided by the square root of 150 gives us 0.0040. Okay, that's 0.4%. Okay, if you think about a small number like that, 0.0040. That's our standard error of our sample. So now we find our student's t-value. Okay, we say t with a degree of freedom of 149. Okay, we do that from, remember, degree of freedom is 1 minus the sample size. So our t-value of degree of freedom, okay, it's the average from your sample minus the standard, minus the average that you were looking for, okay? Divide that by our standard error of our average. So our average was 0.0913 from the sample. The average we were comparing it against was 0.08. Okay, that was from the problem or the null hypothesis. Divide that by the standard error, which was the standard deviation divided by the square root of the sample size. And we get 2.825 when we round this. So usually we get a z-score when we go to the z-table. Well, this is a t-score, and we can sort of go to a t-table, but at best for this class, for this book, you can only estimate it unless you have a like an advanced calculator, which in class, the TI-84s we usually use, and it takes 7 seconds or so to type it into a calculator. Just type a couple buttons and it gives you the answer. But there is a way to sort of do it by hand, to estimate it by hand. I'm going to show you guys both. Okay, so the first way you can estimate this is if you go to your book, and you know where we have our z-table here in the back. Let's zoom out. So if you go to your z-table in the back of your book, right, and this is where we get our z-scores and we find our probability. That's what we're going to try to find here in a moment, the probability of getting that z-score or that t-score. So usually we do something like this. So with something like 2.825, there's 2.8, there's 2.80. We're looking for 2.83. So 1, 2, and 3. I would take this and I could subtract that from 1 because that would be the left side shaded. We're looking for the right side shaded. Okay, and so I would get about 0.23 or 0.0023, which is close to what we get, but it's not the exact answer, and I'll show you how to get the exact answer. Okay, so here is the estimated way to get it, is to turn the page and go to what's called the table T, okay? If you look, it says table T. This is our values of T. And right here is our degree of freedom. So degree of freedom 1 would be a sample size of only 2. Okay, you see these numbers all kind of like correspond to whatever your degree of freedom is. Our degree of freedom was 149. What they say with degree of freedom that's not on here specifically, okay, so you see where this is degree of freedom over here, ours was 149. They say whatever if your degree is above the number on here, they say to go to the next one down. So we'd go down to 180, okay? And somewhere along here is going to be an estimation of our number, okay? Or it's probably going to be somewhere in the middle. Here's what we're looking for. So when we have a t-score of 2.825, okay, what you want to do is match it up down with a number down here. Now, our number is not on here. It's actually off the chart. So we're looking at these numbers right here. They have the same numbers here on the outside for your t-value or for your degree of freedom. So you can kind of match it up. Ours, okay, was what? Ours was 2.825. That was our number, 2.825 for our T 149. 2.825 is above this. Okay, so what you're supposed to do is go up then to the very top of the page. And what does this say? Okay, at the top of the page. So it's a far right column, top of the page. You see how I have those numbers up there, 0.01 and 0.005. So that is for one tail probability or, sorry, two tail probability or one tail probability. Okay, so this is a greater than problem. If I was to draw this out, okay, if I was to draw this out, if that's like 0, 1, 2, 3, okay, 2.825 would be around here, and I would just be shading the greater than. Okay, I would just be shading the greater than right here. Okay, it would just be the greater than, it would just be this side over here shaded. That's at 2.825. So the right side shaded, that little itty bitty piece in there, okay, 2.825. Remember the degree of freedom. All right, so one more time. Down here, degree of freedom of 149 would drop down to 180. At 2.825 was my t-score, okay? And so I find it on here, and then I go to the top. It's going to be the one tail probability for 0.005. So that's an estimation of my numbers, about 0.005. However, the actual answer is a quarter of that, even 0.0027. This is the exact actual answer. Okay, your p-value of that. Okay, that is your answer, 0.0027. If I didn't have technology, I would have put 0.005. Okay, but I'm going to show you with technology how to get that exact answer. Okay, so I went ahead and found this StatTrak website, stattrek.com. Okay, so I put that link, student t-test calculator, right here. Okay, click on that, and this page comes up. Okay, t-distribution. It says, what are you trying to find? It says t-score or sample mean. We're trying to find the score, the t-score. Degree of freedom, 149. What's the t-score we found? 2.825. Okay, so we're going to leave the bottom one blank. Okay, I'm going to hit calculate, and it gives me 0.9973, but we notice on the calculator there, it says less than. We want the greater than. This is also, once again, a left side shaded calculator, okay? So 0.9973. So at that point, take away 0.9973. Woo! 3. And that is the 0.0027. Okay, that, for whatever fun reason, it's, yeah. Sure, whatever. Nice. I don't know. Good times. So 0.00 0.27. So there's a way to estimate it and a way to get it, and the best way to get it, the exact number, is just from a online calculator, or if you got an advanced calculator, which this is not an advanced calculator. The Texas Instruments ones, the bigger ones, the crafting calculators, they're the ones that have all the fun stuff with it. Okay, so that's how I got the 0.0027, was just from a calculator like this. A StatTrak calculator is just one of them. Okay, so how did I do that? Once again, you got to have your degree of freedom, 1 minus your sample size. Sample size of 150, so 149. And find the t-score. Okay, well, what is, sorry, the random variable you're given is a t-score, right? So the t-score you have, 2.825, that was what was given, right, into in your problem. And you're trying to solve for that probability. Okay. And when I did that, that's where it gave me that probability, but that's the left side shaded. I wanted the right side shaded because my problem was greater than. All right. So final answer would be that p-value. And so since we have a small p-value, we will reject the null hypothesis. Okay, so we're trying to figure out. But yeah, it was a 0.09 something, right? The 0.0913. But is that a significantly bigger amount than 0.08? Our statistics, the work that we did, shows that it's a small probability. So therefore, yes, we're going to reject the null hypothesis and say that this is good, that we think it's greater than that. Okay, we have evidence. So that is it for this chapter. There's a little bit more that you can do, but we're not going to do that right now. We'll do that on Thursday. You guys should have enough to kind of get going with your homework and classwork stuff. Okay, I'm going to stop the video.